Okay, so welcome to the course of signal and system. So what is the concept of signal and system? Okay, what is the concept of signal and system? So the concept and theory of signals and system are needed, basically it is needed are needed in almost all electrical engineering fields. Okay, and in other engineering and scientific discipline. So basically what is signal? Okay, so let me define what is signal. So basically let us define what is signal. So if you consider a simple RC circuit, let us consider a simple RC circuit, then this is voltage, there is current in this circuit, and the voltage across the capacitor is Vc. So basically you can say that the current which is flowing across the resistor, and the voltage across the capacitor is signal. So mathematically a signal, is represented mathematically a signal is represented as a function of an independent variable t, and what is that t? So usually t denotes time. So usually this t denotes time. Okay. Now you can classify signals. So what are the various classification? First is you have continuous time signal, the first classification is continuous time signal and discrete time signal. Then second classification is you have so let us take an example of continuous time signal. So this is an example of continuous time signal, that is xt with respect to t. Basically the t is continuous variable. So a signal is continuous time signal if t is a continuous variable. So if t is continuous variable, then it is continuous time signal. But if t is discrete variable, but if t is discrete, like we have xn, so basically this is discrete, that time, this is discrete time signal. So this is an example of discrete time signal. So basically that n is discrete. This n is discrete variable. Now we have another classification. The next classification is real and imaginary signal. So yt equals to sin t, cos t, all these are real signals. So these are real signals. Basically the imaginary part is 0. Basically the imaginary part is 0 for real valued signals. So if we have imaginary signal, then suppose xt is an imaginary signal. So suppose xt is an imaginary signal, then it can be represented in two forms, that is real part plus j into imaginary part. So what is xre? It is basically real part of xt. And what is xim? It is nothing but imaginary part of xt. So we have real signal as well as we have so this is basically an example. So basically we can take an example like yt equals to e raised to the power j 3t. So basically you can write it as cos 3t plus j sin 3t. So basically cos 3t is nothing but real part of e raised to the power j 3t. And what is sine t 3t? It is nothing but imaginary part of e raised to the power j 3t. So this is an example of complex. Basically it is an example of complex signal. So this is an example of complex signal. So in slide what I told you that real and complex signal, basically real and complex signal, not imaginary. Okay. Next is further we can classify the signal in as a deterministic and random signal. So basically what is deterministic signal? So what is deterministic signal? So deterministic signals are those signals whose values are completely specified for any given time. Thus a deterministic signal can be modeled by a known function of time t. Can be modeled by known function of time t. So is there any so we can give an example of deterministic signal, like we have yt equals to 5t. This is an example of deterministic signal. Now there is random signal. So basically that the signal is changing for every instant of time. So noise signal is random in nature. Like if we consider the AWGN noise. So the AWGN noise is basically that additive white Gaussian noise. Its full form is additive white So this additive white Gaussian noise basically it is represented as 0 sigma square, that is 0 is basically that mean is 0 and variance is sigma square. So this is an example of random signal. Okay, so AWGN noise is an example of That's why that modeling of noise is very important in when we are going to analyze the channel fading. Okay. So there is another classification that is very important classification. Further, we can classify signal as even and odd signal. So we have even and odd signals. So what is even signal? If xt is an even signal, then x of minus t should be equals to xt. For example, if xt equals to cos t, then x of minus t is equals to cos minus t, that is equals to cos t. So it is nothing but xt. So cos t is basically an even signal. If we draw the graph of cos t, then this is our cos t signal. So we can see here that there is symmetry. That signal is symmetric along the signal is symmetric along the y-axis. We can see that there is even symmetry. So the signal is symmetric along the y-axis. Now, if the signal is odd signal, if the signal xt is odd signal, then we have x minus t is equals to minus of xt. So let us take an example. Xt equals to sine t. What is x minus t? So x minus t is sine of minus t, that is minus of sine t. So if we draw the graph, then we are getting the odd symmetry. You can see here, this is our graph of sine t. So basically we are getting the odd symmetry. So we are getting the odd symmetry. So here we are getting the odd symmetry. So this is odd symmetry. Now we can represent any signal in terms of even and odd components. So the signal xt can be represented as a sum of even signal and odd signal. And what is that odd even component? How to calculate the even component? So even component is written as xt is equals to xt plus x of minus t divided by 2. And how to represent the odd component? So x naught t equals to xt minus of x minus t divided by 2. So for example, we have xt equals to e raised to the power jt. Then what is even component? xct, it is e raised to the power jt plus e raised to the power minus jt divided by 2, that is cos t. And what is odd component? So what is odd component? x naught t is nothing but e raised to the power jt minus e raised to the power minus jt divided by 2. Now divide and multiply both numerator and denominator by 2. So what we will get j sin t. So we will get j sin t. So the even component, let us summarize, the even component of e raised to the power jt is cos t. Odd component of e raised to the power jt is j sin t. Further, we can also represent the discrete time signal in terms of even and odd component, like we have xn equals to xen plus x naught n. So basically this is xen, basically this is even component of xn, this x naught n is basically odd component of xn. So how to write xen? That is xn plus x of minus n divided by 2. Then how to write odd component? xn minus of x of minus n divided by 2. Okay, so likewise here we can find out the even and odd component of discrete time signal also. So basically these are formulas to find out the even and odd component for discrete time signal also. So let us take an example of even signal. So this is an example of even signal. You can see there is symmetry along the y-axis. Now if we just draw this diagram, this type of diagram if we draw, then this is an example of odd signal. Why? Because there is symmetry along the opposite, there is symmetry in opposite quadrant. So this is even signal. So this is even signal. This is odd signal. So the symmetry, so for even signal, the symmetry is along the y-axis, and for odd signal we can see that the signal is basically symmetric in opposite quadrant. Okay, so these are some classification of signals. So some basic continuous and discrete time signal we can study. So some basic signals are there, some basic. So some basic continuous time signals. So there are some basic continuous time signal. The first signal is del t. So this signal is basically how to represent the del t. So del t is basically del t equals to infinity for t equals to 0 and it is 0 for t not equals to 0. So basically for t equals to 0, the amplitude tends to infinity. So we can see from this diagram, for t equals to 0 the amplitude tends to infinity, and for the rest of the values we can see that it is 0. So there is another definition for this unit impulse, that if we integrate from minus infinity to plus infinity del t dt, the area should be equal to 1. Another signal is unit step signal. So how to represent the unit step signal? So unit step is basically how to define unit step? Unit step is basically ut equals to 1 for t greater than n equals to 0. It is 0 for t less than 0. So how to obtain unit impulse from unit step? So basically if we differentiate the unit step, we will get the unit impulse. Third signal is ramp signal. So what is ramp signal? So ramp signal is basically TUT. So RT is basically TUT. So it can also represented as RT equals to T for t greater than or equal to 0, 0 for t less than 0. So these are some basic signals. Now we have further we have some classification of signal, like we have energy signal, and power signal. So how to calculate the energy of signal? How to calculate the energy of continuous time signal? So what is the formula? So energy of continuous time signal, so that it is represented by E equals to limit t tends to infinity integration. So also just we can remove this integration. We can write from minus infinity to plus infinity modulus of xt square into dt. So this is the formula for calculating the energy of the signal. So there are some few properties. If xt is an energy signal, then what is the property? Xt should be non-periodic. Second thing is xt should be bounded. So these are two properties that. And what is power of energy signal? So the power of energy signal is equals to 0. So this is very important property. First property is that xt what is the necessary condition? That first is xt should be non-periodic signal. So generally periodic signals are power signals and non-periodic signal are energy signals. So next thing is power signal. How to calculate the power? So if the signal is periodic, then periodic signals are power signals. And what is energy of power signals? So energy of, if we calculate the energy of power signal, then energy will be equal infinity. The energy will be infinity. Second thing is we can define the energy and power for discrete time case also. So let us define the energy and power. So for discrete time case, for discrete signals, how to calculate the energy? So for discrete time signal xt, xn, for discrete time signal xn, energy is equals to summation n equals to minus infinity to plus infinity modulus of xn whole square. Now how to calculate the power? So power is basically limit n tends to infinity one divided by 2n plus 1 summation n equals to minus n to n equals to plus n modulus of xn whole square. Okay, I forget to tell you the formula for power for this continuous time case. Okay, so power for, so calculation of power for continuous time. So what is the formula? Power equals to limit t tends to infinity 1 divided by t minus t by 2 to plus t by 2 modulus of xt whole square dt. So this is the formula for calculating the power of, this is the formula for calculating the power in case of continuous time signal. In case of continuous time signal, that I forget to tell you. So let us calculate the power. Let us calculate the power of few signals. Like we have also we have del n, that is a unit sample. So what is that del n? Del n is basically for n equals to 0, the value is 1. And rest of the value it is 0. So del n, what is del n? Del n equals to 1 for n equals to 0. It is 0 for n not equals to 0. So what is energy of del n? So energy equals to summation n equals to minus n to plus n limit n tends to infinity modulus of xn whole square. So basically if we remove the limit, then it is minus infinity to plus infinity modulus of xn whole square. Now what is xn? So xn is basically del n. So we can apply here. So it is del n square. Now what is the energy of this signal? So basically if we see the property of del n, then property of del n is that del n is only defined for n equals to 0. So at n equals to 0 in this summation, basically in this summation, for n equals to 0 only, this summation exists only for n equals to 0, and rest of the value is 0. So from n equals to minus infinity to n equals to minus 1, we will get 0. At n equals to 0, the value of del n is 1. So we will put 1 here. Then from 1 to infinity also we will get 0. So basically our solution is 1. So the energy is basically 1. So energy is 1 joule. Now we have un. Now we have un. So what is un? It is 1 for n greater than or equal to 0. How to plot un? The plotting is like this. It is 0, 1, 2, 3, 4. So basically this is unit step response. This is unit step signal in discrete time case, and it is 0 for n less than 0. So how to calculate the energy? First you can see that it is a non-periodic. It is non-periodic. So can we calculate the energy? Yes, we can calculate the energy. So what is the energy? Summation n equals to minus infinity to plus infinity modulus of xn whole square. Now what is the energy? Summation n equals to minus infinity to plus infinity modulus of un whole square. Now we can see that from n equals to minus infinity to n equals to minus 1, un is 0, so 0 square, and from n equals to 0 to n equals to infinity the value is 1. Okay, so finally what we will get, this is 0, this is 0, this summation will gives us 0, basically. So this summation is basically will gives us 0, and this summation, so what is that summation, n equals to 0 to infinity 1. So how many times we are going to add 1? Basically we are going to add 1 infinite times. So what is that, what is the meaning? Basically it is infinity, so basically energy is infinity. It is very surprising. So what is the surprising, it is very surprising result, because we know that why it is surprising, because we know that if signal is bounded, and non-periodic, then energy is calculated. But if xn equals to un, what is the energy? Energy is infinity, basically unbounded. So this is very surprising result. Okay, the basically what we are getting, the energy is equals to infinity. So there are some exceptional cases. Now there are some signals for which we can calculate the energy and power. Like we can calculate the power of sine 4 sine omega naught t. Or we can calculate, better to take, okay, no problem, we can take sine, no problem. So calculate, what is the question? So there is question. So question is calculate power of yt equals to 4 sine omega naught t. So what is the formula for calculating the power? What is the formula for power calculation? So it is power limit, basically limit t naught tends to infinity, 1 divided by t naught, 0 to t naught. We are considering only for one cycle. 4 sine omega naught t square into dt. Here basically we are considering power. Basically if we calculate, if we see the graph of sine t, so please don't confuse about why I have taken t naught. So please if we analyze that, then period is basically this is our 0. So this is our 2 pi, this is our period, that is this is our sine 4 sine omega naught t, and this is time t. So basically what is omega naught? So what is omega naught? Omega naught is basically 2 divided by t naught. So basically what we are doing, we are calculating the power for one period only, because it is a periodic signal. So we are going to calculate the power for only one period. That's why I have taken here T naught. So basically either you take from T minus T naught by 2 to plus T naught by 2 or 0 to T naught. Basically we are integrating across one time interval. So what is the result? Limit T naught tends to infinity 1 divided by T naught 0 to T naught 16 sine square omega naught t into dt. Now we can apply the formula here. So what is sine is omega naught? So sine omega naught is nothing but 1 minus cos 2 omega naught t divided by 2 into dt. Now if we open this, we can write it as limit T naught tends to infinity 1 divided by T naught 0 to T naught 16 divided by 2 into dt plus 0, because if we integrate any sinusoidal signal for one complete cycle, what we will get? So let me write the final answer, then I will explain why the second term is 0. Let us write it in separate page. So basically if we are going to integrate the sinusoidal signal across one time interval, then positive area and negative area will cancel out. So what is happening that what is the final result we are getting? We can apply here this 8 okay, then we have 8 into 2, that is 16 watt. So what is the power? What is the power of 4 sine omega naught t? So power of 4 sine omega naught t is 16 watt. So there is shortcut method for calculation of power for periodic signal. So what is the shortcut method? So the shortcut method is that if we have xt equals to a sine omega naught t plus phi or a cos omega naught t plus phi, then what is power? What is average power? Just see the amplitude. Basically, what is average power? Just see the amplitude. Just see the amplitude and square that amplitude and divide by 2. So this is the power. So let us take an example. What is power of 15 cos 4t plus 90 degree? What is power of this signal? So the power is 15 square divided by 2 watt. Now if we change the phase angle, and if we change the frequency also, now what is power of this signal x1t? So power of x1t will also 15 square divided by 2 watt. So the power will remain same. Basically, power only depends on amplitude. Power depends on amplitude. So basically, these two signals, they have same power. Now we can calculate. We can further analyze the. We can further find out the energy of some exponential signals. Like we have this. This signal, we can calculate the energy of this signal. So what is the question? Calculate the energy and calculate the energy and power of xt equals to e raised to the power minus 3t into ut. So how to calculate the energy? So first draw this figure, that is xt with respect to t. So the figure is like it is a decaying exponential. It is a decaying exponential. At t equals to 0, the amplitude is 1. So this is the graph of e raised to the power minus 3t. Basically ut equals to 1. So we are not getting any part. Let me explain this again. So basically we have two signals. First signal is e raised to the power minus 3t and second signal is ut. So what is graph of e raised to the power minus 3t? The graph is like this. And what is graph of ut? The graph is like this. Now if we multiply these two signals, then ut is defined only for positive quadrant. So basically we are getting this type of signal. So this is graph of e raised to the power minus 3t multiplied by ut. Because ut is 1, so we are getting signal only in positive quadrant. So we can summarize this, that minus e raised to the power minus 3t ut equals to e raised to the power minus 3t for t greater than or equal to 0. It is 0 for t less than 0. So how to calculate the energy? So the energy calculation is also, it is non-periodic. It is non-periodic. So it is non-periodic signal. So we are not going to calculate the power, because non-periodic signals are energy signals. So what is energy? It is minus infinity to plus infinity. So how to calculate the energy? It is minus infinity to plus infinity modulus of xt whole square into dt. So it is minus infinity to plus infinity modulus of e raised to the power minus 3t into ut whole square dt. Now we can apply the property of unit step function. So what is the property? So from minus infinity to 0, from minus infinity to 0, this e raised to the power minus 3t into 0. Why? Because ut is 0. Because ut is 0 for t less than 0. So for t less than 0, ut is 0, and for t greater than 0, ut is 1. So from 0 to infinity we have e raised to the power minus 3t into 1 square dt. So finally what we can do, we can solve this integral. So it is 0 to infinity e raised to the power minus 3t square dt. It is e raised to the power minus. So further solution leads to, what we can do here, we can just square it. Okay, we can just square it. So what we will get, so basically whatever result we are getting, basically it is less than infinity. It is less than infinity, it is bounded, it is less than infinity. So basically what we are getting bounded. So energy is bounded. So basically we are able to calculate the energy because it is bounded. So energy is bounded. Okay, for e raised to the power minus 3t into ut. Now the reverse is that if I am giving you an example like xt equals to e raised to the power 3t into ut, so can we calculate, the question is, so another example is, can we calculate the energy of e raised to the power 3t into ut? So what is the answer for this question? Can we calculate the energy of e raised to the power 3t into ut? So first thing is that let us check whether it is periodic or not. So of course it is a non-periodic signal. It is non-periodic because if we see the graph of this signal, the graph is like this. So this is the graph of e raised to the power 3t. Now if we analyze the graph, what we observe, it is unbounded. So it is unbounded signal. As it is an unbounded signal, so we are not able to calculate the energy. So we are not able to calculate the energy. So basically e raised to the power 3t into ut, we cannot calculate, because if we calculate then we will get that energy equals to infinity. If we apply the formula here, that is minus infinity to plus infinity e raised to the power 3t into ut whole square dt. So what we will get, we will get 0 to infinity e raised to the power 3t whole square into dt. So basically it is infinity only. So in this way, because it is an unbounded signal, so we are not able to calculate the energy of this e raised to the power 3t into ut. So what we did, what we can see here, that we have two signals. First signal is e raised to the power minus 3t into ut. Second signal is e raised to the power 3t into ut. So both signals are non-periodic. So this signal is also non-periodic. This signal is also non-periodic. both signals are non-periodic, but it is bounded. It is bounded. So this one is bounded signal, but it is unbounded signal. It is unbounded signal. So due to this energy we are able to calculate. Energy calculation is there. Energy calculation is possible. Here we are getting energy equals to infinity. So this is not an energy signal. So this is not an energy signal. And it is an energy signal. It is an energy signal. Okay, so let us calculate the let us take another example. So let us take an example of discrete time signal, that is xn equals to 1 by 4 raised to the power n un. So this is a discrete time signal. So let us calculate the energy. So question is calculate the energy of this signal. So let us solve this problem. So let us solve this problem. We can calculate the energy of this signal. So first we draw the signal. So the signal is basically, it is discrete time signal. So for n equals to 0, please calculate the value. What is x0? So for n equals to 0, the value of this signal is 1 by 4 raised to the power 0. And what is un? Un equals to 1. So what is the definition of un? Un equals to 1 for n greater than or equal to 0. It is 0 for n less than 0. Okay, so for n equals to 1, what is x1? x1 equals to 1 by 4 raised to the power 1 into 1, because u1 is also 1. So for n equals to 2, this x2 is 1 by 4 raised to the power 2, and so on. So we can represent it as the signal xn 1 by 4 raised to the power n un equals to, for 0 it is 1, for n equals to 1 it is 1 by 4, for n equals to 2 it is 1 by 4 square, for n equals to 3 it is 1 by 4 cube, and so on. So the first value, this value is corresponds to n equals to 0. The second value 1 by 4 corresponds to n equals to 1. This is n equals to 2. This is n equals to 3. Now we can draw the diagram. We can draw the diagram. How to draw the diagram? So we have xn with and the discrete time variable n is on x-axis. So basically for n equals to 0, what is the value? 1. For n equals to 1, what is the value? 1 by 4. For n equals to 2, what is the value? 1 by 4 square, that is 1 divided by 16. 1 by 16. For n equals to 3, we have 1 divided by 4 cube. So it is decreasing. We can see that the amplitude is sorry, I have made a mistake here. Actually, that amplitude should be less than 1 only. So here we have 1 by 4, that is exactly 1 by 4 times of 1. So there is mistake here. Sorry for that. Better to draw again. It's better to draw again. So for n equals to 0, the value is 1. For n equals to 1, the value is 1 by 4. Then we have 1 by 4 square. Then we have 1 by 4 cube. So basically for n, when we are going to increase the value of n, it is decreasing. The amplitude is decreasing. So the amplitude is decreasing. So first thing is clear that it is from the graph, it is non-periodic. So from the graph we can see that it is non-periodic signal. Second thing is that it is bounded. It is bounded signal. Why? Because we can see that, we can observe that the amplitude is decreasing. Amplitude is decreasing here. We can see that the amplitude is decreasing. If we take n equals to 4, then it is 1 by 4 raised to the power 4. Then it is further, it is 1 divided by 256. So it is decreasing continuously. So what is the energy? What is the formula for calculation of energy? It is summation n equals to minus infinity to plus infinity modulus of xn whole square. So from n equals to minus infinity to minus 1, what is the value? 1 by 4 raised to the power n into 0. And from 0 to infinity, and from n equals to 0 to infinity, n equals to 1, from 0 to infinity, what is the value? It is 1 by 4 raised to the power n into 1, because un is 1 for n greater than or equal to 0. So finally what we are getting, summation n equals to 0 to infinity, we have 1 by 4 raised to the power n. So for we can apply the series. We can, basically it is GP. So basically it is GP. It is GP. So what is first term? So basically what is first term? I am writing here. So what is first term? First term is basically 1. What is second term? second term is 1 by 4, then we have common ratio, that is 1 by 4 only. So what is the solution of this series? First term divided by 1 minus common ratio. So it is 1 divided by 4 by 3, 3 by 4, sorry. So it is 3 by 4, that is what is the result? 4 by 3, and it is less than infinity. So what is the energy of 1 by 4 raised to the power n un? So energy is basically 4 by 3. I did a mistake here, okay. Sorry, there is mistake here because we haven't squared this. It is basically 2n, so 2n. So it is basically 16. Yeah, I did mistake here. Sorry for that. I missed that point. So basically we have summation n equals to 0 to infinity. We have 1 divided by 16 raised to the power n. So the instead of that second term is basically 1 by 16. The second term is basically 1 by 16. So first term divided by 1 minus common ratio. So basically what we are getting? We are getting what is the final energy we are getting? We are getting 16 divided by 15. So energy is basically 16 divided by 15 joule. Sorry for the mistake. So what is the energy? And all of us we can easily observe that this is a bounded. This is bounded. And this is in less than infinity. So what I mean to tell you that energy of 1 by 4 raised to the power n un is 16 by 15, and that is less than infinity. So it is basically bounded. It is basically bounded. Now let us calculate the energy and power of. Let us do another example so that we will understand better. So question is calculate energy and power of Xn equals to e raised to the power 10 Jn into Un. So how to calculate the energy and power of this type of signal? So basically we can see that it is a periodic signal or non-periodic signal. First we have to see that whether it is a periodic signal or non-periodic signal. So basically we have multiplied this signal with un. So let us calculate. We can't say that it is a periodic signal, okay, because it is restricted only in positive cycle, half cycle. So can we calculate the power? Yeah, so let us calculate the power. What is power of that signal? So power, what is the formula of power? So power is basically limit n tends to infinity 1 divided by 2n plus 1 summation. Sometimes it is happening that if you have a non-periodic signal, then in the case of un you have calculated the energy and it turns out to be infinity. So there are some exceptional cases. So for this case also we can check the power. What is the power? So what is the formula of power? That is limit 10 tends to infinity 1 divided by 2n plus 1 summation n equals to minus n2 plus n modulus of xn whole square. Okay, so this is the formula for calculation of power. So let us calculate the power. So what is the power? So it is a limit n tends to infinity 1 divided by 2n plus 1 summation n equals to minus infinity to plus infinity modulus e raised to the power, what is the question please? E raised to the power j 10 jn. Okay, thank you. 10 jn un square. Now we can see that due to multiplication of unit impulse, unit sample, unit step, this summation will go only from 0 to infinity. Why? Because un is only un is only exists for n equals to 0. So un is equals to 1 for n greater than or equal to 0. It is 0 for n less than 0. Only exists. So for n less than 0, you can see that there are no samples. And for n greater than 0, you have samples. That is equals to 1. And this is nothing but 1 for n greater than or equal to 0 square here. Then we have limit n tends to infinity 1 divided by 2n plus 1 summation n equals to 0 to infinity. What is that value? What is the modulus of any complex number? That is 1 only. So what is final result? Limit n tends to infinity 1 divided by 2n plus 1. So how many times we this is n equals to this is n equals to minus infinity minus n2 plus n. Okay, so basically this is n equals to minus n2 plus n. So it is plus n because we haven't applied the limit. Okay, we haven't applied the limit. So how many times we are going to sum this one? If you see that we are exactly going to sum this from we are going to sum this one to n plus 1 time. Okay, so what is the final result? If we apply the limit, so how to apply the limit? So before that we can do one thing. We can we can divide the numerator and denominator by capital N. So we will get 1 plus 1 divided by capital N, and better to write in next page. Okay, so limit n tends to infinity 1 divided by 2n plus 1 plus n plus 1. So if we apply the limit, if we divide the numerator and denominator by capital N, then what we will get? Limit n tends to infinity 1 plus 1 divided by n 2 plus 1 divided by n. So what we will get finally? We will get 1 by 2, that is less than infinity. So what is the power? So power is basically 1 by 2, that is less than infinity. So this is the power of e raised to the power j 10n into un. Now we have if we calculate the energy of this type of signal, then we will always get infinite energy. So energy, if we calculate the energy, you can check the energy is infinite. Okay, because if we have power signal, then the energy will be equals to infinity. Okay, so what is that thumb rule? If we have power signal always has infinite energy, and if we have energy signals, so energy signal have zero power. Energy signal has zero power. If we calculate the power of the energy signal, then it will be equals to 0. It will be equals to 0. Okay, so thank you all of you.